Morning, everyone. Welcome to another Gravity Masterclass. I hope you guys are all doing well, staying safe and following all the regulations that you should, the hand sanitizing, the social distancing, all that. I'm glad you can join us wherever you are. Today we'll be discussing anchor points. My name is Danie Nel. I'm an employee of Gravity Training. So we're glad you're here. Welcome. Today will be quite an interesting one. I think it'll be informative for many of you. It's something a topic that we come across quite often in all scopes of work at height, rope access, follow rest, rigging, all of it. So it's quite an essential part of our work and of our industry. So I hope you get something valuable out of it. I hope you enjoy it. Before we get into the actual meat of the presentation, just a bit of admin first. For those of you who haven't joined us before, and for those of you who've never joined a MS Teams live event before, just a few things to make your life a bit easier. I just have an example of the screen you should see in front of you. Just go to the slide. So on your right-hand side of the screen, you should see the tab or the section that says Live Event Q&A, and then Ask a Moderator, and then below that you should see your name, brackets optional, and then Ask a Question. So during the masterclass, you're welcome to ask me a question if you want something explained again, if you want me to go through something again, if you want me to include something that you felt I might have missed, you're welcome to. You'll see on the top right, it says My Questions, then you'll be able to see the questions that you've posed. And then our moderator, Yandre, will then publish the questions so that everybody else can see them. So if you switch between My Questions and Featured, you'll be able to see the questions asked by other people, as well as yours. And then under My Questions, you'll be able to see your own, of course. Please do include your name where it says your name, so that we know who to address when we're answering the question, so you know that it's your question that we're answering. Okay, so as I said, we are here for Gravity, and I'm representing Gravity Training today. Just to give you some background about Gravity, the Gravity Training is a member of Gravity Group, as well as Gravity Access and Gravity Gear. So you're welcome to contact us on info@gravitygh.co.za for any general inquiries. If you want to ask a question, if you want to inquire about our services, or if you just want to find out what we're about. If you want to book a course, you're welcome to contact bookings@gravitygh.co.za. Or you can visit our website as well at gravitygroupholdings.com. And Gravity Group Holdings, as I said, they includes Gravity Training, Gravity Access, and Gravity Gear. Gravity Training, obviously specializing in work at height training, rigging, follow rest, rope access. Gravity Access, specializing in work at height access solutions, installation of rails and anchor points and lifelines and so on. And then Gravity Gear, specializing in work at height equipment. So all three of those companies are under the Gravity Group banner. So if you go to the Group Holdings website, you'll be able to access all three of those profiles, and you can see what they're about and download price lists and brochures and all that kind of thing. For those of you joining us for the first time, this is the fifth masterclass we've done. The first one was done by Johan Strauss on the pitfalls of designing a full production plan. Then the second one was also Johan Strauss, we did on rigging. Then Heinrich Schroeder did one on rope access, and then Heinz Stapelberg did one on equipment. I also did one on low-level heights as well. All those previous masterclasses are available on YouTube. So if you go to our profile on YouTube at Gravity Group, excuse me, you'll be able to see the recordings of all the previous workshops as well. You can also follow us on Facebook and Instagram for all our latest updates. We are continuously operating during the lockdown for people, companies who have been granted essential services. So you're also welcome to contact us via Facebook or Instagram. Right. So the agenda for today is as follows. First of all, we'll discuss the problem posed by anchor points. Now, with the problem, I mean the typical mistakes people make, the typical misconceptions that people have regarding anchor points, and we'll go through a few photos that I've got of unsafe anchor points and people using anchor points incorrectly to give you an idea of what I'm talking about. And then we'll discuss the risks involved in using unsafe anchor points or using anchor points incorrectly. Then we'll quickly have a look at the types of anchor points. Then we'll have our first tea and coffee break. And then when you come back, we'll look at the planning for anchor points. And then anchor installation requirements, anchor testing, permanent anchor systems, and then a tea and coffee break, and then we'll have a question and answer session after that. Now, the idea behind this masterclass is not to give you all the information on how to go out and install and test anchor points. This is more of the philosophy behind anchor points and anchoring. So to give you an idea of the importance of being competent and being trained and ensuring that the guys you have on site using anchor points, installing anchor points, testing anchor points are competent and have the right information at hand. Okay, so let's get started. First up, the problem. Unsafe anchors. So obviously on the left, you'll see that the technician, if I can use the word loosely, has chosen to use a unsecured rod through this bracket and then connecting a carabiner to that. Now, a few major issues should pop out straight away if you know anything about anchors. First of all, this whole rod can just move out, causing the whole anchor to be useless. Secondly, the carabiner is not locked, it's upside down as well, and the knot is not dressed properly, and the rope is quite swelled with chemical damage or whatever it may be. So the danger of something like this is it's unsecured, it's unsafe, it is not tested, it's not certified, it's not approved by any manufacturer, and it poses a risk for this anchor and this worker connected to this line to be unsafe in terms of that anchor can go away and then he will no longer have any connection to the structure, which will then cause or prevent any fall arrest or any fall protection system from actually working in the case of a fall. And then on the right-hand side, you'll see the guy who used steel cable saddles on a kern mantle rope on a hanger, which is also in quite poor condition. Now, again, these types of DIY, self-improvised solutions to a problem is extremely dangerous, as this is in no way, shape or form approved by any manufacturer or allowed. So there's no guarantee of the strength of that anchor or the reliability of that anchor. The mechanical connection of those saddle clamps are designed to work with steel cable or steel wire rope. So the effectiveness on a kern mantle rope is untested, unproven. And this anchor point, not tested, not marked, also a danger, which leads me to believe that if this system should experience a shock load or a fall impact, it will not hold, it will not be sufficient to protect the user sufficiently. Hey, next up, we have the users not trained in the use of anchors. So you'll see the guy on the right-hand side here. He knows about using a harness, he knows about using double shock absorbing lanyards, but he does not know about connecting to a safe anchor. You can see he's connected to telephone wires, it looks like. So obviously, if he were to fall off that edge, he will just snap those wires and probably still hit the ground, judging about the length of those shock absorbers and then obviously the flexibility of those lines as well. So an incompetent worker will usually also be unaware of which anchor points are safe to use, how to use them correctly, and which systems are compatible with that anchor system configuration. So it's very important that besides the anchor points being installed correctly and tested and all that, which we'll come to later, it's extremely important that the users are trained in using that system as it's intended by the manufacturer of the PPE and of the anchor point. So next up, we have the incorrect use of anchors. So you'll see here that the technician or whoever installed this used the correct knots, carabiners locked, carabiner seems in good condition, rope seems in good condition, but now we have the issue of this knot being pulled in the wrong direction. Using a figure of 8 knot like that is unsafe. As you can see, it opens up the knot at the bottom here, reducing the strength of that knot quite substantially. And the other issue we have is that this passes over this metal structure or member, whatever it may be, without any edge protection against those sharp edges. So although this technician had the right idea in terms of using the correct equipment, he is using that combination, that configuration of anchor points in the incorrect way, which also then leads to unpredictable responses from the equipment. So we don't know how that knot will react should somebody fall on it. We don't know how that rope will react over those sharp edges and so forth. So incorrect use of anchors is very common in terms of people improvising solutions on site with all the correct equipment, with all the correct materials at hand, and still deciding on the incorrect solution. So just a few more to give you an idea of what we're talking about. Again, guys using improvised solutions on site, using these deadweight anchors. As you can see, hopefully, that none of these things are correctly fastened to the rooftop. They're not inspected. They're not certified. These knots are in terrible condition. Only one of them is taking any weight. So again, this points to somebody who has had some form of training, or at least maybe watched some YouTube videos, and chose to trust his life or the life of somebody else to this anchor system without following the correct procedures and the best practices that have been set out for us. All right. This one on the left-hand side, you'll see the guy, his two friends helping him out, keeping him safe from the roof edge while he's working in these gutters. Doesn't seem that bad until you get to the right and you see at what height he's actually working. Now, obviously, if that guy were to fall or to slip, that guy standing on a sloped roof won't be able to hold his weight, and then most likely two of them, or if not all three of them, will actually end up falling. So this is a great example of a worker not understanding the risks involved in work at height, and especially, for example, rooftop work, where even though it's not a straight vertical surface that he's working on, he believes himself to be quite safe because he is on a sloped roof and he's crouched down, so he should be fine. Now, again, this comes down to training. If this guy is properly trained, he would understand the risks involved in rooftop work, being especially one of the more dangerous aspects of work at height, as we've covered in the low-level heights masterclass, which you can go back and look at on YouTube. This guy is unaware of the risks, thinks he's safe, and therefore does not take the correct precautions in terms of his footrest system and, by extension, his anchor system. And then this one, perhaps one of the worst ones, is these window washers improvising an anchor for a temporary suspended platform, or a TSP, by using these rods or beams with deadweight anchors on top. Now, again, most of these solutions do exist. Deadweight anchors is something that is allowed to be used, but again, any form of anchoring that you use should be certified, tested, inspected by competent people. Improvised solutions like this pose a significant risk to the users and to the public at large. For example, if you take this environment, working on the side of a building, then obviously there should be a walkway or a public access road at the bottom of this building. So if these guys were to fall and if this anchor system were to fail, not only will these two guys be in big danger, but the public walking below and passing underneath this these two guys will obviously be in big trouble as well. You can imagine the weight of that thing coming down on you can cause some serious injuries. So again, the problem that we face in most of these cases is the issue of people misunderstanding the risks, people misunderstanding the effects of anchor points, the importance of anchor points, the way that we use them, and misunderstanding the mechanics of it, and misunderstanding the way that the force you impart on an anchor point will cause it to react a certain way. People underestimating the forces generated by a fall, by a dropped object or something like that. So it's extremely important that people who do work at height, people who install anchor points, are very aware of the risks involved in anchors and in work at height. They understand the mechanics, they understand the forces involved, and that they take these risks on board, and they do, obviously, as Johan talked about in these FPP masterclass, is it all comes down to risk assessment, of course. But after the risk assessment, the implementation of that risk assessment is down to the supervisors on site, the technicians on site, to take that to heart, to use those risk mitigations correctly. Okay, so let's quickly have a look at the risks involved in anchor points. So first of all, the obvious one is if you use an unsafe anchor, or if you use an anchor incorrectly, you will run the risk of anchor failure. The actual anchor system can break or fail or pull out of the material that's bolted to, which obviously then puts the worker either in a position where he falls, or where he won't be protected in case of a fall. So the second one is equipment failure. Now, meaning that if you use an incorrect anchor, if you choose an anchor which is insufficient for your task or your access method, for example, if you, like the image we saw earlier of the guy using the figure 8 knot of the carabiner over the sharp edge, if you use that anchor incorrectly, then the rope can get cut on the sharp edge, which will lead to the rope failing, which will lead to you no longer having a fall arrest system, or it might, in the rope access case, might actually lead to you falling. Then, as we saw with the TSP guys with that improvised deadweight anchor on the rooftop, can lead to items falling. So if the anchor fails, or if your equipment fails, even if you don't fall, the equipment around you may fall. So the TSP could fall, or if one side of that collapsed, all the paint buckets and tools and stuff can fall off that TSP, for example, which can cause injury to other workers on below you, or indeed the public. And then the other one, of course, and the big one we want to prevent at all costs, is persons falling. Okay, so persons can fall due to anchors failing, due to equipment failing, due to items falling on them. So as for the risks, and as for the effect that anchor points have on our daily activities on site, it's extremely important to understand how to do these things correctly and safely, and how to use anchors correctly and safely. So before we go on the tea break, just to give you a heads up on what's coming after the tea break, we'll be looking into planning for anchor points. Now, I don't mean the actual how to fill out the documents and risk assessment part of it. Even though that's extremely important, that's something that will be covered in your training and the courses that you can do for anchor points, and for like the RopeX level 3 guys and the full protection plan developer guys. So for this masterclass, I'd like to focus, as I said earlier, on the philosophy of anchor points. What do you look for? How do you think about them? What makes a good solution versus a bad solution? What's a good option versus a bad option? And what are the things often overlooked and misunderstood about anchor points? So if you're interested, please stick around. I'd love to have you here. And then we'll continue after a quick 5-minute coffee and tea break, stretch your legs, get something to drink, and then we'll see you at 25 past. Thanks. Right, welcome back, guys. I hope you had a enjoyable break. Just to recap what we said from before the break, if you don't mind me repeating myself quickly. The idea for the next session is to go through the planning phase of anchor points, as well as a few definitions and so forth. So the next bit will be quite technical, but hopefully you guys will stick around to the end to see the implementation of that. So first of all, let's look at the standards involved in anchor points. So typically, most people in most countries will use EN 795, the standard for anchor points. Now, again, I forgot to say at the beginning, for our international viewers, we are operating in a South African context, so some of these things might be a bit different, but for the in terms of the work at height regulations and the legal requirements and so forth, but the EN 795 is quite universal, and quite a lot of countries operate under that, not only the European countries. But again, if you operate on the ANSI standards or the Australian standards or something like that, bear with me. I believe these definitions are quite common and quite similar across the standards. So according to EN 795, we have 5 types of anchor devices. So we have the type A, which is an anchor device with one or more stationary anchor points while in use and with the need for structural anchors or fixing elements to fix the structure. Now that's the important one. It's an anchor that needs to be fixed to the structure. Okay, so that's type A. Type B is an anchor point that does not need to be fixed to the structure. Okay, type C is a flexible anchor line. Type D is a rigid anchor line, and type E is the deadweight anchors that we talked about earlier with those guys on the TSP on the rooftop. So type A anchor devices. Type A, that's the one that we use for full arrest anchors or rope access anchors, the planned installed anchor points that we know. Type B anchor devices are, as you might have guessed, slings. Petzl and gravity slings have a EN 795 type B certification, a rating. Type C anchor devices, it's, for instance, a cable, steel wire rope lifeline, again, installed by competent person, all that thing. Type D will be a rail lifeline, horizontal lifeline, and then type E anchor devices will be your deadweight anchors. Now, again, as I said earlier, you saw the picture of the guys on the rooftop with the TSP and the 2 beams with the sacks of cement or whatever it was as the deadweight anchors. Deadweight anchors in themselves are not an issue, but they have to be certified and they have to be certified as type E anchor points. It's not just something you can improvise and make up on site. Okay, that counts for all of these types. If you use an anchor point, it has to be certified as per EN 795 or whichever regulation your country is using. For the purposes of this masterclass, going forward, I will refer to 795. Now, big thing, full arrest anchors, rope access anchors have to be type A, the installed anchor points, and then type B for your slings and stuff. So those are the 2 main ones that we'll be talking about, and we'll have a quick look in at type C as well later on in the masterclass. So within this world of type A anchor points, rope access anchor points, we usually have a secondary definition between the anchor points. We either use self-identified or planned. Okay, for this thing, this masterclass, I will use the word structural, perhaps to make it a bit more obvious what we mean. So in this image here, you can see the technician has used these railings with slings and carabiners, and there's another one going down there, there's a sling going up there with a carabiner. You slung this foot of the stairs as well, and he's sharing the weight on this line through all these different anchor points. Okay, so now you can see, hopefully, that none of these anchors that he's using is certified as rope access anchor points. And what I mean with that is they don't comply with this definition of a type A anchor device. Okay, so even though he's using slings, which might comply to the type B definition, this entire system is self-identified, meaning that the technician on site deemed this safe to use and strong enough. Okay, for rope access work, for forest work, installing lifelines and stuff, that's fine, as long as it's done by a competent person with the proper risk assessment and identifying that these anchor points are of sufficient strength. Now, again, this one might be a bit so-so. For example, the sharp edges are down here, not covered properly, not protected against properly. That handrail there might not be extremely strong, but the good thing this guy did was, rather than relying on just that one anchor point, which might not be strong enough, he did share the weight between all these other anchor points, reducing the strain on each individual anchor point. But then you can look at, for example, the angle between these two loops and those two loops brings up other issues. We'll talk about that later. So the issue with the self-identified anchor points is it relies heavily on the technician's competency and experience to know what's safe and what's not safe. And that's why it's so important to have the correct training, as well as to have competent supervisors on site when dealing with sites and situations where you have to use self-identified anchor points. Okay, and just a note on the reason why I refer to these as structural. These elements which this guy used to connect his system to, they are part of a separate structure. They are part of the staircase, or if you are in telecoms, they are part of the lattice mast, or if you're on a mine, it might be part of the gantry, or whatever it may be. These things were installed and erected with another purpose in mind. So they form part of the structure, and they were there for a different reason. Okay, and therefore we have to identify these anchor points as safe enough or not. Okay, so the alternative is an installed anchor point, or what we typically refer to as a planned anchor point. Now that's something like this. This is the gravity access hanger. We'll talk about these in more detail in a second, but this is a typical rope access anchor. Okay, it's, again, you can see that it's certified to SANS 50795, or in this case EN 795, and this has to be installed by a competent person, and then it has to be certified and inspected and signed off, having a certificate plaque like that. Now, this is the certificate plaque Gravity Access uses when installing permanent lifelines, permanent systems from Full Protect, which, if you remember from the previous slides, conform to the Type C category. So you'll see the EN795 Type C or Type D, depending on if it's the secure rope or the secure rail systems. We'll get to those in a second. So again, the installed anchor points have to be installed by competent people, and it has to be tested and certified. It has to be tested annually as well, but we'll get to more detail later on that. The main thing I want to bring to your attention with these planned anchor points is that they are not something you can buy over the counter and just go and install yourself. There are quite stringent rules on how to install these and how to use these afterwards, which we'll get onto in future slide. Okay, so planning for anchor points, as we said. Now, the first thing we have to look at is the substrate, or the material, as I refer to it. So that refers to the material that the anchor is installed in. Okay, so if you look at a concrete wall, for example, if that's your wall, you drill a hole into that wall and you put your anchor point there. Then the substrate material will be this concrete wall. Okay, if you're using I-beams and you want to install an anchor point on an I-beam, then your substrate will be the steel of that I-beam. Now, again, that is extremely important, and it's extremely relevant in terms of how strong your anchor point will be, and if the anchor point you have in mind is compatible with that substrate or that material. For example, steel anchor points, you have to have the same type of steel anchor than the substrate steel to avoid corrosion and rust and electromagnetic effect. So extremely important for the guy installing the anchor points to understand the substrate material and the strength and limitations of that substrate material. Okay, then we get to the intended use of that anchor point. Will that anchor point be used for rope access? Will that be used for forest, or will it be used for something like rigging? Now, an extremely important stopping point here is that we've talked about the 795 anchor points, and I mentioned that they apply to the forest and rope access anchors. They do not apply for rigging. Okay, so any anchor points that you want to use for rigging purposes have to be signed off by an engineer or a similarly competent person. Okay, so the 795 anchor points, we limit them, or we are limited by the 795 standard to rope access and forest anchor points. Rigging stands alone, has to be certified and signed off by a competent person such as an engineer. The rest of these bullet points do apply to all of these, so you don't have to worry about that. Just keep in mind the 795 anchor points does not apply to rigging anchors. Okay, so the intended use of the anchor point, it will determine the strength, the direction, the amount of anchors, all those kind of things. So be very aware of what you want to use those anchors for. And again, make sure that that intended use is included in the installation process. So don't install a forest anchor point and then use it for rope access, for example. Then we have to consider the direction of use. We will talk about that in more detail in a second as well. The direction of use of anchor points are extremely important, because some of these anchor points have been designed and manufactured with a given direction in mind, having a certain direction of an axis of force which is stronger than the other axis. I'll get to that in a later slide as well. So remember, if you want to use an anchor in a certain direction, consider that before you start placing anchors and using anchors. Then mobility restrictions, I'll get to that in a second as well, in more detail, but that refers to placing an anchor in such a place that prevents the user from actually reaching the areas where they need to work. Okay. Then, of course, always consider the number of users on a given system so that you ensure you install enough anchor points of sufficient strength to compensate for those amount of users on that system or lifeline or anchor point, whatever it may be. Okay. And that is especially important when it comes to rescue requirements. So if you consider something like a rope access environment where a person will be working on, let's say, a double rope system such as that, and if he's working on a double rope system like that, these anchor points, if your rescue plan includes this person being rescued from the same rope system, those anchors have to be strong enough then to take two people, seeing as the rescuer also need to access this, the casualty using these anchor points. If you prefer, then you have to have a separate rope rescue, and that'll have to be included in your rescue plan and your risk assessment. Okay, so again, number of users are quite important, and don't forget to include that number of users, or to include your rescuer in that number of users as well. Okay, so as I promised in the previous slide, to talk about the direction of use and the use of rope access anchor points. Now, the anchor point on your screen now is an example of what we call a hanger, due to the fact that it is designed to be installed into a surface and then used in a parallel direction to that surface. So if you had a vertical surface and you installed the hanger there, you would use it in parallel, forget it, the same direction as the wall. Parallel, my English is leaving me. Most hangers are not designed to be used in the perpendicular axis for this in this anchor point, seeing as you would then pull the anchor point out of the substrate. Now, the one on your screen, the gravity access anchor point, if you can see that, it might be a bit blurry on your screen. This specific gravity access anchor is designed to be equally strong in both directions. Okay, so this is a special case of hangers where the hanger has been designed and tested to be strong in both directions. However, that's not the case for any and all hanger anchor points, so be very careful to follow the manufacturer's instructions and recommendations and the limitations given by them when installing and using anchors like these. Typically, if it has a 25 kilonewton rating in the parallel direction, it'll have a reduced strength to about 15 kilonewtons in the perpendicular axis. Okay, so be very careful. You don't use your anchor points in a direction that is not approved or not sufficient strength in your applications. Okay, so to give you a better idea of what I mean about that, we quickly go to the next slide where I have a bit. I'm going to try and draw you some pictures to explain my points a bit better. So first of all, let's look at the mobility restriction we talked about earlier. If you were to take a front-facing view, okay, so let's say here's your building, and let's say for this case we use rope access as an example. Okay, so there's your this is a terrible drawing, but anyway, I hope you get the point. So there's your windows, and you need to watch those windows. If you were to place your anchor points there, then the user will have easy access to the left-hand side of this building, all these windows. But for him or her to access this part of the building will be quite difficult, seeing as it'll put tension on those ropes and the ropes will keep wanting to swing back. So he won't be able to effectively and easily reach this side of the building to clean it or to do whatever he needs to do. So in that case, you have the option of installing just erase those anchor points. So the other option then, of course, is install the anchors in the middle. So now the guy can have access to the middle of the building and then some access left and right, but not to the far edges of the building, but he should be able to reach about there and the middle without too much hassle. Okay, but again, that would involve him to incorporate some small swings perhaps, or some other form of work positioning to allow him to work on the edges of the site. So obvious choice and the best choice in your planning phase for this is to predict that and to then have anchor points on all three areas so they can move the ropes and this whatever system they're using to wherever they need it. Another option, example of this is if you are in a full rest position on a rooftop, say, and you have your anchor point there and you want to use a work restraint system and you need to work there. The problem is the only way you can work here is if you have a long enough lanyard to allow the person to reach this area. But that now creates an issue where this entire edge now becomes a danger zone, because if he steps over and back, that lanyard won't be long enough to prevent him from falling over the edge. Okay, so having the anchor point there limits his movement to a very small section of this roof, and obviously that will have to be the exclusion zone as well. So again, solution would be to have multiple anchor points, or indeed to have a permanent horizontal line installed there so that the guy can move effectively and easily to cover the entire surface of the work area. Okay. If you have any questions about these kind of things, guys, please remember to put them in the comments. Otherwise, I have no idea if you're happy with my explanations or not. So please feel free to ask some questions, and we'll get to them at the end. Okay, now anchor distance is something that many people overlook as well, and this also falls into the explanation we had, the discussion we had earlier about the direction of use. So if you were to use, say, a hanger, and you were to place it here, and you had your ropes anchored, and they go over this parapet wall, and you're working there. You see that angle there is quite small. Okay, so the further back you go, the smaller the angle will become, the closer you'll get to that optimal direction of that word I can't say. Okay. However, if you use that same anchor point and you place it very close to this parapet wall, say there, and you rig your ropes, you're now pulling that anchor point straight up again, okay, which is not ideal for certain. Again, the gravity axis hanger, this doesn't apply, but the more common, the standard anchors do have this problem. If you're on site, and from some of the older sites may still have eye nuts on them as well, this will be the opposite case for the eye nuts. If you're, let me just start this drawing over. If you have a rooftop with a parapet wall and you have an eye nut there, for example, the further away you are, the closer you get to pulling that eye nut in a shear direction. Okay. Meaning sideways. Pulling straight up, we refer to as tension, sideways as shear. Eye nuts are designed for force in the tension direction, hangers are designed for force in shear direction. Okay, so the further away this anchor point is from your parapet wall, the more dangerous it becomes because you're pulling it in the incorrect direction. If you put that eye nut closer to the parapet wall, again, you get closer to pulling it in the correct direction. Now, all of this, of course, can be avoided if you actually put your anchor points or your hangers, for example, in the parapet wall, as then you'll be in complete shear force, which is the safest, or if you put your eye nut, which we don't recommend, there. Okay, but again, bolting into parapet walls and those kind of things do come with its own limitations and its own restrictions, which you need to know. You have to be trained and competent to do that safely. Okay, one more note on anchor distance is if you look at the top, and if you can remember as far back as that example we used of the guy with the self-identified anchor points and the ropes, we talked about the angle between his double loop figure 8s. Okay, so if you have two anchor points equally on the same level, equal height, and you have a load suspended on this, like that. Again, I won't go into the details on this here. This will be included in your training courses. If that angle is 120 degrees, for example, and this is 100 kilograms, each of these anchor points will feel 100 kilograms, and the larger this angle becomes, the more that force increases. The smaller the angle, if that angle was 0, for example, you had the same configuration, it'll be 50, 50. Okay, so when you're placing anchor points and you're using anchor points on site, if your anchor points are too far apart and you're using something like a double loop figure 8 or any load sharing anchor point where you use 2 anchor points to suspend one load, that angle becomes extremely important in terms of how strong your anchors are and what amount of force that anchor can take. Okay, now you have 2 solutions for this one. For example, first one is you make these legs or whatever system you're using longer. Okay, so that will mean that you have your anchor points there, and then all the way down here, you'll have your figure 8 or your Y-hang, whatever it may be. So that angle then becomes significantly smaller. However, this distance now becomes quite big, which may cause some problems depending on your site and your work area, your size of the roof, whatever it may be. And the other option, of course, is just to have your anchors, to choose or place your anchors closer together to make sure you manage that angle properly. Okay, so always keep in mind on your anchor points, there's also a minimum distance that you have to maintain, but it is given by EN 795, depending on how deep you go, what size anchors you're using, what side thread you're using, and so forth. So always refer to a competent person when using anchor points like these. Okay, I hope that made sense. Again, that will be the previous slides with the case for full arrest and for rope access. Planning for anchor points in terms of rigging, of course, becomes another ball game. Again, these types of anchor points, we refer to these as a gin pole, which allows you to extend an anchor point off of a tower, for example, to give you some more leverage and to give you some more space to work. Extremely important that you do the calculations for the forces involved in a lift like this. If you look at on the left-hand side, due to the distance there being quite small, the amount of force you're putting on this bracket and that bracket is relatively small. Whereas this creates quite a large moment and will put quite a significant force, sorry, wrong direction, quite a large force on these brackets. Okay, and that's why it's so important that you have these designs, these anchor points signed off by competent people such as engineers, because the forces involved here are extremely complex and it's very difficult to predict the forces involved, like we do with full arrest, because we can, if we assume 150 kilograms per person, the calculations become quite easier and we have a safety factor of 10. So we are quite happy with using predetermined anchor points. Guys using the manufacturer's requirements and stuff like that when installing anchor points. Whereas with rigging, it becomes quite complex, especially with heavy loads in terms of upwards of 100 kilograms, 500 tons, those kind of things. Or not 500 tons, 500 kilograms to a ton. It becomes quite significant especially in the telecoms industry. Okay, so talking about anchor point installation, again, referring to the 795 for full arrest and rope access, it has to be done by a competent person. Okay, it has to be done according to a standard. In South Africa and in Europe, we used EN 795, and of course, you have to have your risk assessment in place for the installation as well. How the guys get to the areas where they have to install their anchor points. That's most often quite a difficult job to plan for, seeing as you don't have the anchor points yet to make your job safe. So the risk assessment there becomes extremely important. The planning that we talked about now in terms of how many do you use, how far apart do you put them, what direction will they be used, will they be used for rope access, will they be used for full arrest. Make sure that you have that planning in place and that you involve a full position plan developer as well. They will be able to assist you with things like, if you put the anchor there, it may have a risk of a swing back or swing down, those kind of issues, which again Johan Strauss went through in quite great detail in his masterclass. And then of course, make sure that all your installed anchor points are marked, specifying the limitations of that anchor point and the standard that they have been installed to, as well as who they were installed by. so that you can follow up and hold somebody responsible if that marking is insufficient or needs updating, whatever the case may be. Okay, now again, a lot of the same rules apply for the anchor point testing. For those of you who don't know, testing of anchor points usually involves a hydraulic tester like this. So you connect this thing to your anchor point and you turn that handle and it pulls to a certain force, whatever the required force is. But again, all these tests have to be done by a competent person according to the standard relevant in your country. In our case, it's 795 for 4S rope access anchors. They have to be tested annually, and they have to be marked again with the date of testing by a competent person. Same rules as with the installation, who, by, when, and the results of that test has to be kept on file as well. Okay. For those of you who are curious, if a anchor point has lapsed and it's outside of this annual test, other test conditions do apply, and again, competent people will assist you in how to recertify anchor points, or in most cases those will be destroyed or removed, new anchors will be placed and tested and certified. Now again, if you are curious about more of these things, Gravity Access do offer all these services as well, the installation and testing and certification of the anchor points. So if you do need any of these services on your sites, please, you can contact, again, info@gravitygh.co.za to get in touch with us, and Gravity Access will be more than happy to assist you with any of your anchor or access solution needs. Okay, so the last few things I want to talk about before we get into the Q&A is just a quick look at the permanent 4S systems. So these are two examples of Fall Protect secure rails, the horizontal and the vertical. Now these, as we saw at the beginning of the masterclass, fall under the EN795 type C for the rails and EN795 type D. EN795 type C for the secure rope and EN795 type D for the secure rail systems. So all the requirements that we talked about on the previous slides about testing and certification and marking apply exactly the same to any permanent 4S system that you might have on site and that you might want to use on site. It has to be installed by a competent person according to the relevant standard, has to be marked, who installed it, when, the inspection date, signed off, number of users indicated, all these limitations and requirements that apply to your 4S anchors, apply to your 4S systems, your permanent 4S systems as well. And again, Gravity Access specializes in installing these Fall Protect systems, the ropes and the rails. So if you require any assistance on these, please do feel free to contact them as well. So if you would like to learn more about the things we discussed in this masterclass, we are at the end of the of the presentation. We'll go into the Q&A after a short break, but before we do that, if you are interested in learning more about this, Gravity Training does offer the Fall Protection Plan Developer course, which goes quite deep into planning for work at height and ensuring that the people on site are safe and that you have the correct systems in place, that they've been installed correctly, having the procedures and the policies in place to ensure that you have a safe site. All those things are covered in that course. And of course, for now, the level 3 rope access supervisor are the guys who are trained on installing rope access anchor points and testing them and so forth. So if you're interested in that, please contact bookings at gravitygh.co.za. If you are interested in the access solutions, please contact info@gravitygh. And of course, don't forget about Gravity Gear if you need any equipment. They are currently running some great specials on some equipment, so you're welcome to visit our website as well, or our Facebook page will be updated with their specials and all the offers of Gravity Gear as well. All right, so thank you very much, guys. That's all from me for the presentation-wise. I hope you learned something. We'll have a quick 5-minute tea break, and then when we come back, I'll quickly have a look at the questions that we've received, and I'll answer them as best I can, and then that's all from us today. So see you guys in 5 minutes. Thank you very much for joining us and watching. I hope you learned something, and see you in a bit. Thanks. Right, welcome back, guys. Let's quickly have a look at these questions. We have a few good ones that came in. Excuse me, I'm not looking at the camera. I'm reading the questions on a separate screen here. So first one, Bolaji. Apologies if I mispronounce your name. So you asked, what is the best way to anchor a rooftop while working at a height if no anchor hook installed on the rooftop? Okay, so again, rooftop work, more dangerous than people realize. I would recommend that you go back and watch the low-level heights masterclass that I did a few days or a few weeks ago. But to give you the short answer, it comes down to your risk assessment. If it's a fragile roof, for example, or if it's a rooftop with unprotected edges, then I would recommend that you get somebody to install anchor points before you go up there. There are other ways to do it. For example, you can use those deadweight anchors, but again, have to be certified. The deadweight anchors are quite difficult to obtain and quite expensive as well. But for the best part, I would recommend that you do install the anchor points before you use a rooftop. Just due to the fact that it's one of the leading causes of accidents on site next to ladders, as we discussed in the low-level heights one. So as far as possible, get somebody to come install rooftop anchors for you. If it's determined by risk assessment that it's needed. In the low-level heights masterclass, we discussed when is a full risk, and so forth. So go and have a look at that. But my recommendation was, if you don't have anchor points, get some and make sure that you're as safe as possible. You won't regret not having them. Okay, next one is from Shakil. What kind of equipment can be used to test an anchor point? Okay, so let's quickly go back on my presentation. I'll share the slide with you in a second. Let's just see. So I'll quickly share this slide with you again. So there are various makes and models of this type of hydraulic tester. Okay, so these are the best ones to use. They are reliable, sturdy, accurate ratings, and they're quite nice to use actually, and they're quick and easy. And as I say, very reliable. So for anchor testing, I recommend something like this. It doesn't have to be the ultimate one, but as I say, there are quite a few different makes and models of it. So I hope that helps. There are a few, I can say, lower tech solutions as well, but they all function on the same principles. So get yourself a anchor tester or a hydraulic pull tester. That's the alternative. Okay, so then another one from Shakil. Must two anchor points be used at a time, or one for main and the other one for backup? Okay, so good question. That is referring to rope access. For those of you who are unfamiliar, rope access requires you to have two ropes at all times, 2 points of contact. So you have a main line and a backup line. So if your main line fails, you'll spin on your backup line. And if you have 2 lines, your main line, as they call it, is your work positioning line. You move up and down on that. Should that line fail, your backup line will catch you. So Gravity's recommendation is to share the main line on 2 anchor points and to share the backup line on 2 anchor points. That's just an extra level of safety. So you have 2 anchor points on your main line, 2 anchor points on your backup line, so that if your main line anchor fails, you're still on 2 ropes, okay? Rather than shock loading or impacting your backup line alone, your backup anchor alone. However, if you go to IRATA and ISO standards and stuff, it is allowed to use one knot, one anchor, one knot, one anchor for backup and main. The requirement is 2 ropes independently anchored. Okay, one for your main, one for your backup. So again, yes, you can get away with using one anchor point, they have to be separate and not connected and not shared in any way. So if the one fails, the other one will catch you. But my recommendation and Gravity Training's recommendation is that you use 2 anchor points shared for mainline and 2 anchor points shared for your backup line, just as an extra safety precaution. So short answer, use 2. Okay, then Ivan asks, people are working in scaffolds, are they allowed to anchor on scaffold guardrails? If yes, can you explain how many people can anchor on it, its capacity and ratio? Okay, so most steel scaffolding will have a safety rating or a safe working load of 250 kilograms per square meter, the ledges and the standards and stuff. So that's for the ledges and the guardrails on top. If you're referring to the topmost rail, the guardrail, the hip bars, they are not rated for full arrest anchor points, but then you can make the argument that when you are in that environment, if you're on the top of a scaffold with the trapdoor closed with the enclosure around you of the guardrails, then that becomes a barricade. So then you are technically no longer in a full risk position, as you can't step over the edge. So those guardrails serve as a physical barrier to protect you from falling. So the amount of force that they are required to withstand will be less than the full shock load and the full impact of a person falling on them. So you'll see guys on top of scaffoldings. I assume when you mention guardrails, you refer to the very top of a scaffold. You'll see guys working there with their shock absorbers connected to the topmost bar. Those are not there or not intended to then go and climb outside of the scaffolding and hang on that or use it for a full rest system. Okay, they're purely there as a work restraint system and to keep the guys from forgetting to use the full rest. So it's still better than nothing. So I won't recommend that you just take off everything you have while you're there, even though you are in a safer environment or in a reduced full risk position. So the guardrails can be used as anchor points, but I won't recommend using them for full arrest anchor points. So if you're working on the inside of the scaffold on the top, it's no longer a full risk position per se, so you don't really need the full arrest anchors. Otherwise, the ledges and standards of scaffolding, typically steel scaffolding, has a 250 kilogram per square meter safe working load, so you can take that as your limit for amount of users allowed on a certain section in terms of rescue and planning and so forth. Okay, I hope that helps. Then Sean asks, how will you know if equipment or anchors are tested if no certificate are available at the time of installing anchor points, and how do you test or inspect it on site? So again, the rule is if you arrive on site and you see an anchor point and there's no certificate, you don't use it. Okay, you never assume anything. You don't kick it a bit or inspect it, and if you don't see anything wrong with it, you use it. If there's no certificate and if the inspection is out of date, meaning it's not been inspected in the last year, you don't use it. And then you contact a competent person, such as Gravity Access, and they will come and test or reinstall anchors for you. Okay, so there's if there's no certificate, you assume it's not been tested, and you assume it's not been installed by a competent person, and therefore you don't use it. Okay. Another one from Sean. On site, when installing anchor points on a building or surface, how will you know the strength of the anchor point? And that will carry the employees on equipment. What is the best way to test the anchor point? Okay, so a quick summary of anchor point testing. So according to the EN 795 standard, if you install an anchor on a site, let's say the roof of a building, into concrete using rope access hangers, you do one installation according to the standard. I won't go into the detail of how big the bolts and how deep the hole and all that kind of thing, but anyway, you install that anchor point as per the standard, as per the manufacturer's requirements. Then you do what they call a type test. So then you use one of these Hilti testers we talked about earlier, or these hydraulic pull testers, and you put a force of 12 kilonewton onto that anchor point for 3 minutes. Okay. After that, those 3 minutes have passed, and if that anchor point is still holding, you then know that the substrate material, the concrete in this case that you're bolting into, is of sufficient strength and is in a good condition, that the chemical that you're using for your anchor points bonds properly, which then allows you to guarantee that that anchor point will be strong enough to take the impact of a fall. From there on, the subsequent anchors you place in the same concrete. Again, if you move to a different part of the site, you have to do a type test again. But then you do a strength test, which is 16 Newton for 15 seconds, and then you sign off each anchor point. You record evidence of those tests being done. And then you can sign off the strength of that anchor point as per the manufacturer's recommendations. They'll give you guidance in terms of if you use an M16 bolt in this type of concrete, this deep, with this chemical, and installed in this manner, it will give you a minimum breaking strength of 22, 25 kilonewton, whatever it may be. The minimum requirement set forth by 795 is 12 kilonewton, but then you have to use 2 for certain situations and so forth. But the main rule of thumb is that you test it according to 795, and then you use your manufacturer's instructions and requirements to then certify the strength of that anchor point as per their recommendations. Okay. Who's this? Romano, he asks, what if no anchor points of any sort of fall protection, or any sort of fall protection, excuse me, is installed and the guy has to go and install anchor points? What is required? Now, similar to I forget his name, sorry, just check. Bolaji's question about how do you work on rooftops if there's no anchor points there. Again, what is required for you to go and install anchor points, if there aren't any already, is a very decent fall protection plan with a comprehensive risk assessment. Okay, and of course, competent supervisors, competent technicians. So in any situation like this, where it's a site establishment project, where you have to be the first people to go and install anchor points for guys who have to use the site after you, those kind of things, your risk assessment, your fall protection plan is extremely important to get it right. I mean, it's always important, but you have to think out of the box, and you have to think of a lot of other situations that can go wrong in terms of how you anchor yourself. Now, the short answer is what is required is you use a competent company like Access, for example, Gravity Access. They have years of experience doing this, and they have tried and tested methods of installing anchor points. And the short answer is most likely you'll have to use a different access method to get to that area to install the anchor points. And that different access method is usually a more advanced one, which requires more training, which results in you having to use competent people such as Gravity Access. So the main thing is, if to answer your question for what is required, it's a risk assessment and a comprehensive fall protection plan. And most likely you will have to use an outside company such as Gravity Access. So Johnny asks, what about anchors for work restraint? Is there a standard for it, and what force are they expected to withstand? Very good question, and this is one of those ones where I struggle to give you a straight answer. There's no standard for work restraint anchor points in terms of how strong they have to be, because they are assumed that they will never have to withstand a fall. They won't have to absorb the shock load and the force generated by somebody falling on. So using a work restraint anchor point and connecting the anchor to a wall, the most force you expect them to withstand is the force of a person pulling against them with their own body weight. So it's negligible amounts of force given a steel beam or a concrete pillar or something like that. The big problem with that is that's assuming that the guy using that system will always use that system perfectly, and there's no chance at all of him messing it up, getting the lanyard wrong, the length of the lanyard wrong, or something like that. Okay, not misjudging the areas where he's allowed to work, not to work, not moving into exclusion zones, stuff like that. So if you are confident and your risk assessment is done and your people are competent and trained, whatever, all the rest of it, you can use self-identified anchor points for work restraint anchor points. Again, common sense hopefully will prevail. Again, identify these anchor points in your risk assessment in terms of your fall protection plan developer has to go and do a site visit, inspect all the anchor points. Then if you're on site and you decide, okay, I'll use that for work restraint, make sure that it's strong enough that if somebody pulls on it, it doesn't break or deform or become unstable. Okay, so the minimum breaking strength of something is difficult to pinpoint, but the obvious, or not the obvious, the short answer is that it's something that you should be able to be confident and trust that it will hold the forces that you expect to see. Now, the forces you expect to see depends on the use that you put on it. So my recommendation is assume your work restraint anchors and like I said, treat your work restraint anchors the same you would your self-identified anchor points. So something that you would use to connect a lifeline to, for example, a vertical or horizontal lifeline, use the same, how can I say, the same limitations, the same requirements that you expect from your anchor points that you'll use for a lifeline. Use those same ones for your restraint systems, just to be on the safe side in terms of making room for human error in terms of people misusing a system or misunderstanding a system in some way. So there's no standard, unfortunately, but treat them as if it's a self-identified anchor point for any other forest system. And the forces that you have to deal with, expect the worst. Expect that somebody will fall on it due to unforeseen circumstances. Okay, not necessarily incompetence. Okay, then Mihai asks, on anchor point is written number of users. Does that mean how many times it was used or workers on it at each time? So I think, sorry, that might just have been my South African accent. That refers to the amount of people allowed on that system at a given time, not the amount of people who have used it in the past. So it's not number of uses, it's number of users allowed on a system. Okay, that'll be obviously dependent on the strength of the anchor points and the manufacturer's requirements, saying that if you have this size anchor point and this amount of anchor points, yada, 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 you're allowed to have so many people on them. Okay, so make sure that you always comply with those regulations and you don't push the limits, as like we can have some serious consequences. Okay, and then Anonymous asks, are there any rule of thumb to check if the anchor point is complying? The reason is because while we select an anchor point, we might not always have a certificate in hand for that anchor point at field. Okay, again, if it's an installed anchor point, meaning one of those rope axes or those hangers or iNut or something like that, if it's not certified, you don't use it. There's no rule of thumb to check if it's safe enough or not. If it's not certified, not tested, you don't use it. If it is a self-identified anchor point, on the other hand, and it's something that a structural component that you have to use for your anchoring system, then again, you might get tired of me saying this, but training and competent people in your training for forest or rope access, you will be shown and exposed to different scenarios where you'll get a feel and understanding of what a sufficiently strong anchor point looks and feels like. Okay, and it comes down to experience and good supervision and good training that allows a user to be confident in their anchor point selection. Right? So if it's supposed to be an installed anchor point and it's not tested or certified, don't use it. If it's self-identified or structural anchor point, it comes down to competent people with correct training and experience and, of course, competent supervision. Okay, so The rule of thumb that we use for self-identified anchor points is that we expect a safe working load of 150 kilograms or a breaking strength of 15 kilonewton. If it's going to withstand that, it can withstand a fall of a human being with the little extra room to spare. Okay, so if you need that, it's difficult to you don't test them, so it's something that you get used to identifying on site as you gain experience and as you become more and more confident and competent in your field. Okay, so Johnny asks, how strong should a temporary rope or webbing lifeline anchors be? Again, so I sort of answered that question on the previous one, but again, rule of thumb for self-identified anchor points is 15 kilonewtons minimum, which calculates to a 150 kilogram safe working load. Okay. Again, with sorry, just on lifelines. When using vertical lifelines, that's why we train guys to use 2 anchor points for your vertical lifelines. At the top, use a double loop figure 8 to connect to 2 separate anchor points. That's just to allow for the misjudging of human beings, assuming that this one is 150, so only need one is it's a bit tricky. So we always recommend that you use 2 separate anchor points to be extra super safe, that if the one should fail, you are covered with the other one. Okay, so again, we train 150 kilogram safe working load for self-identified anchor points, but if you are unsure, always double up with 2. Well, you always will be unsure because you don't test them. So always double up with 2 anchor points on separate levels. Okay, Ivan asks, can a company do the anchor point installation for lifelines and later call a third party to inspect and certify? No, you cannot. The installation has to be done by a competent person as well as the testing. So always get the right people out to do the right job correctly and safely the first time around. Okay, guys, I hope you guys have learned something. I hope you enjoyed it. If you want to contact us after this, if you want to have some more questions, you're welcome to go to our Facebook or Instagram page. You can send us messages there. I'll read them and I'll respond to them. Again, the recording for this masterclass we've done will be on YouTube as well. We'll upload it probably tonight or tomorrow, but we'll post something on Facebook and Instagram to let you guys know when this recording is live. If you want to go and revisit something, or if you want to share it with some of your friends or colleagues. So thank you very much again for watching. Please stay safe. Do what you can to help those around you, and hopefully we'll see each other again soon. All right, thanks guys, enjoy your weekend.